Salutations, ladies and gentlemen, boys and girls. Have any of you ever developed a web application with some sort of SQL with an S database in the background and asked yourself, how can I protect my application from all the mean people in this world? If you answered yes, I have prepared one answer to that question that you might want to hear. See what I did there? Prepared and parameterized statements are a tool that every web developer should keep in his or her tool belt at all times. Most frameworks nowadays support them for whatever language or RDBMS you're using in your application. For those of you who have developed an intimate relationship with SQL and web applications already, this presentation is not for you. No. This presentation today will demonstrate the dangers of SQL injection and then outline one good practice that can be used to mitigate those dangers. For those of you who are completely unfamiliar with SQL injection, we'll begin by showing an example of it, and then we'll show a few examples of how it can be prevented. SQL injection, a code injection technique used to attack data-driven applications in which nefarious SQL statements are inserted into an entry field for execution, is one of the three most popular attack vectors used by tech-savvy hooligans and ne'er-do-wells looking to get their jollies from the pain and suffering of others. To provide a real-world example of this danger, let's pretend that your bank of choice for all your financial transactions is Jimmy's Bank of Insecurity. There's no other bank that you would trust with your money. Now, you just recently learned that Jimmy's Bank of Insecurity now offers the ability to bank online. And being the consummate trendsetter that you are, you want to be among the first to use this terrific new feature. So, you navigate to jimmysbankofinsecurity.com on your favorite web browser and you're presented with a login screen not unlike this one. Having created an account during a previous visit to the site, you simply input your credentials correctly into the input fields and go about your merry way. If the person I've described resembles you during your own online banking usage, you're not thinking like a hacker. Instead, let's pretend that when you're greeted by the login screen, your first instinct is not to input valid credentials, but instead you just want to understand a little bit more about the meaning of what it is to quote unquote log in. Logging in is really just the process of comparing usernames and passwords that are input by the user to those that are presumed to be valid in some master list of existing usernames and passwords. In many cases, this master list of existing accounts is stored in a SQL database, and a query is run to find the expected password for a given username. I'm sure, if you're watching this video, this isn't breaking news for you, so let's just jump ahead. Pretend we have a SQL database already set up. Inside of that database, there's a table called users. Inside of that table, there's two columns, username and password. And inside of that table, there are multiple rows of valid credentials. The query and its surrounding code might resemble something like var password equals select password from users where username equals single quote username as a variable single quote. While your particular brand of SQL might vary, this is a perfectly legitimate query, and there are probably hundreds of applications out in cyberspace that have this exact line of code verbatim. Do you notice anything wrong with this line of code? At first glance, you might be tempted to say that everything's fine, but what if I told you that, if you're not careful, this exact query could be executed literally as though you were typing it yourself in a command line client for your SQL of choice? Username could be any number of things. It could have non-Latin, non-ASCII characters. It could be thousands of characters long. And of course, it could even be a valid username. But what if it was also a valid SQL statement? What if the value for username was something like var username equals single quote, semicolon, space, drop table users, semicolon, space, select, single quote. That would mean the statement being executed is exactly select password from users where username equals the empty string, semicolon, drop table users, semicolon, select the empty string. That copy and paste that entire line into a command line client for your SQL database and see what happens. You're not likely to get a syntax error. At best, you'll get an error that a table or column used in the query doesn't exist. At worst, your entire users table will no longer exist. To illustrate this point, I've taken the liberty of creating an example web application using Node.js and PostgreSQL. You can find this application in the GitHub at https://github.com/jimmy-p123/prepare statements. On there, you'll find all of the information necessary to set up and run this application for yourself. At a minimum, you will need PostgreSQL and Node.js installed on your machine. While developing this, I used PostgreSQL 9.6 and Node.js 6.9.2. If your version numbers differ and you encounter problems running the application, please submit an issue to that same GitHub repository. Now, assuming you have the requisite software installed on your machine, your first step will be to create a database in PostgreSQL. So we'll do that now. Mine already exists, but executing the same line for you should not yield that error. Once that's complete, the next step is to clone the repository and change some database credentials if you're not using the defaults. So we'll go and do that now. The default super user is Postgre S with the empty string for the password, and the default port is 5432 for that user. If yours are different, go ahead and change them in db.js. Now, install the requisite node modules using npm install. And then start the server using node server.js. If you already have another application listening on port 80, you will need to edit server.js and change the constant port variable to another of your choosing. Don't worry about the output just yet. Once that's done, open your browser and navigate to localhost. You should now be greeted with a sudo login page with a vault overflowing with gold coins as its background image. To answer your question, no, that is not my vault full of gold. I found that picture through a Google search and figured whoever actually owns that picture is too rich to be bothered to sue me for its unlawful usage, since they own a vault that's overflowing with gold coins. And plus, this is technically educational, and I'm literally making no money off of it. Anyway, instead of just one form for submission like you'd find at your typical bank's website, you have your choice between three. On the far left, you have a form that is completely vulnerable to SQL injection. I advise trying something a little less destructive than our hypothetical example of SQL injection from before, but if you are so malicious, simply restarting the node process after doing that will create the users table anew with default users, which is the output that you saw when you first started the node process. Once you attempt to log in using any of these three forms, your Node.js console output will display the query that is being run to look up the password for the username that you input. To start, try entering a valid username. The three default users are admin, password 1234, user, password, and Jimmy, ABCD. So we'll just do admin, password 1234. Upon submitting the form, you should be greeted with a page like this one here. It will tell you whether you have been authenticated, either success or failure, and the execution time of the query that is being run. Pressing the resubmit button will simply run the same query again, and pressing the go back button itself is pretty self-explanatory. So let's go back. Instead of using valid credentials, let's input into the leftmost form again something like single quote, semicolon, select PG Sleep 5, semicolon, select, single quote, and then anything for the password. That should take approximately 5 seconds. What? This same query completed in fractions of a millisecond the first time around, but now suddenly it's taking thousands? That's because PG Sleep is obviously a PostgreSQL function to cause the process to wait the given number of seconds before continuing its execution. This noticeable spike in runtime for our login query clearly demonstrates that we are at risk for SQL injection. So, what can we do about it? While there may be more, let's talk about two options in particular. First, escaping your queries. Just as single and double quotes and other special characters can be escaped in JavaScript if you need to literally include them in a string literal, you can do the same here. With PostgreSQL, a double set of single quotes will compile to a single quote, and that's how we can escape the user's input here. With MySQL and some other SQL languages, you can escape single and double quotes with a backslash as though it were JavaScript. Now if we attempt to log in using the same malicious credentials from before, we'll see that a single query is run with properly escaped quotes, no username exists with that name, and our application is now safe. So for this new form, exact same, anything for the password, boom, executed in only 1.268 milliseconds. It's a dramatic decrease from the 5 previously. While this option is perfectly viable, it does have one major flaw: the developer who is writing it. Even the most seasoned developers fail to escape queries when they should because they either forget or they don't realize that their statement is vulnerable. You didn't hear this from me, but many photo, toll, and ticketing systems for automobiles on the roadway are vulnerable to SQL injection. If you're looking for a clever way to avoid a speeding ticket and land yourself in jail, a license plate with some correctly placed SQL on it could possibly get you a job as a white hat hacker when you're released from prison in 6 to 12 months. Instead of escaping queries, we can also use prepared statements. Prepared statements are pre-compiled using different sorts of printf style formatting to replace identifiers such as $1 or question marks in SQL statements with the intended variables. In Node.js, using the PG module, as I've done here, these can be used by passing a JSON to the query function that has the SQL to execute with variables replaced by $signs and the corresponding index, an array of values to substitute into the string, and a name as the unique identifier for the statement, meaning two statements executed with the same name are the same prepared statement. If that's unclear, attempting to log into Jimmy's Bank of Insecurity using the rightmost option with the same malicious username and viewing the console output might make it more clear. Instead of executing the statement as it appears, the username is substituted into the statement in place of the $1. So we'll do that now. Anything there. And then we'll pull up the console output again. We'll notice that the literal string passed as the statement contains $1, and the value of our malicious username is passed for the values array. If there's an occurrence of $2, then that identifier would be replaced with the second index of this array here, and so on. Because prepared statements eliminate the risk of SQL injection, it's considered best practice to use them unless you have a compelling reason not to. Many times, the reason not to use prepared statements might boil down to performance. Prepared statements can potentially improve performance when executing the same query multiple times with different values, but executing a prepared statement only once can actually cause the execution time for your application to increase. For example, restart server.js and attempt to log in using the rightmost login form and any credentials, which I have actually done here. This was the first time that I had run that prepared statement since Node started. If that was not the case for you, then restart your Node process. Notice that the execution time for this query took about 3 to 6 seconds longer than the execution time of the other two login functions, but subsequent attempts yield times that are in line with the others. So if I resubmit this, now we're under 1 millisecond. Unfortunately, when talking about fractions of milliseconds, these execution times are within the margin of error. So we can't definitively say that repeated executions of a prepared statement are faster than normal escape queries in this case. However, as queries get more and more complicated, you might see an actual noticeable increase in performance, but your mileage there might vary.